Alright, so I'm here in MATLAB. Let me start Simulink. Oh, it wants to phone home. Let me turn this on. Okay, so here's my MATLAB. Let me go ahead and start a new model. New model. Don't need you. So I need these sources and sinks, these guys. So if I go into source, oh, okay, we'll get sync first. There's the sink I was talking about. So I'll drag him over. And here's my source. And here's the source I was talking about. Just drag him over. And now let's come up with something basic here. Continuous time. Integrator. It's a transfer function. Get over there. So we wire this up just like we do any old Simulink block here, Simulink model. Let's make this more. Yeah, let's take this guy. We don't always do this, but I might for the exam. How about we do 1, 2, 3? I don't know what this is going to give us. There we go. Awesome. Okay, so here's my Simulink model. And I need to run it. Oh, yeah, I did say save, right? Yeah, you have to save it. So let's come up with a name. Just call it Rex, random example. Okay, so I've saved Rex and I'm running. And it ran. I get the nice satisfying ping. And then it go away. If you look over here, I always get some sort of warning message, which is why I ignore every warning message from MATLAB. So I do sys equals limod, D, and I named it Rex, right? Rex, and I think it needs the extension Rex. Maybe not. Let's see. There we go. And so, like I say, you get some sort of information back. It's just some object. So I get that back from my first command. My second is I want to take this and I want actually a state space transfer function or state space model. TSS, state space, sys.a, sys.b, sys.c, sys.d. And if you had me for state space, or you remember your linear algebra, here's your A, B, C, and D matrices. And the way this looks, I'm going to teach you how to teach, right? So here's your transfer function, right? This is the transfer function you guys have seen all semester long. In state space, we represent this exact same thing in state space. It's in the time domain, not in the frequency domain, and it also is represented with matrices. So I end up with, I have a state variable x dot is equal to ax of t plus br of t. So here's my input. Here's an r of s. Here's a br of t. Here's an r of t. B, you can see my column vector B here, 1, 0, 0. So this is sort of an intermediate. This is a hidden process. I've got an input feeding into this system, and then I have my output. Instead of being y of s, it's y of t. So the time domain is equal to c x of t plus dr. So here's your A, B, C, and D matrix. And that's what we get right here. You can see D is just 0. It's a scalar quantity 0, which is often the case. So that is my second line. I've got my TSS, and so now I will pull out the numerator and denominator. So in bracket n comma d is equal to TF data. Yeah, don't yell at me. So we do that, and there's my numerator and denominator coefficients. And so I've got my N and my D, and now just my next step is the transfer function TTF is equal to a transfer function N comma D. And I return. And look at that, it shows it up in a nice, pretty-ish, as good as MATLAB can do. So s squared plus 2s plus 3, numerator, and my denominator is s to the third plus 3s squared plus 5s plus 4. And from here I can type things like TTF. They're the eigenvalues, so it's a stable system. It has 3 eigenvalues, 2 complex, 1 that's not. I could also have done that on my TSS.
Will it factor the leading coefficients for you?
I'm sorry?
Will it keep the leading coefficient 1?
Oh, yes, it does. MATLAB always does that. In fact, sometimes it does it to the point where it's irritating if you would just leave some non.
It'll be simpler, right?
It always does.
Okay.
So there we've got however many steps you want to call that. 1, 2, 3, 4, 5, 6 steps to go from a Simulink model to a transfer function. Any questions? It's a pretty slick thing, and this is actually